So I'm going to talk about a nationwide sensor-based air quality monitoring network which we have developed at IIT Kanpur. I am Sachi Tripathi and I work at Department of Civil Engineering and Center for Environmental Science and Engineering. I'm also a member of Steering Committee of National Clean Air Program, for which I have formed a network of IITs and NITs which is called National Knowledge Network. If you look what these sensors are going to measure, they are going to mainly measure PM 2.5 and PM 10. These are particulate matter, tiny particles of size 10 micron or 2.5 micron or lesser in size. These are very tiny, these are ultra fine particles and therefore very difficult to measure. What you see here on the right, you have a human hair strand which is about 100 times larger than these tiny particles. So that's why they are very difficult to measure and they have a variety of chemical composed in that and which can cause different kind of adverse impacts on human health, which is shown in this slide. So what you see that these small particles, depending on their size, can, while you inhale, can go deep down into the lung, and then from there they can enter into the bloodstream and they can cause a plethora of adverse impacts on human health. As you see that they can cause lung cancer, they can cause a variety of other cancers in different organs, they can create bowel problems, and of course they could also cause heart attack, etc., etc. And it has been estimated that last year only in India 1.7 million deaths were attributed to air pollution only, and globally it goes about 8 million. So when it comes to monitoring air pollution, particulate matter is the main constituent which we want to monitor, which causes 90 to 95% of the human health related issues. So if you look, the current way of monitoring PM 2.5 is by using an expensive instrument which is imported, and that cost around 1.5 crore. So if you look at, if you want to spread it across many cities in the country, it's going to cost you about 4,000 to 6,000 crore. On the other hand, this small sensor and the associated other components which we have developed at IIT Kanpur costs 1/50th of these regulatory grade imported monitors, and only a tiny part of these units is imported currently, which is the sensor, which costs 5% of the total unit, and currently there is a proposal which is under consideration to develop these sensors as well. The complete framework in which this end-to-end air quality monitoring system works, which is developed as a part of a Sattvam project which was supported by Department of Science and Technology. IIT Kanpur was the lead institution, which is called as streaming analytics over temporal variables for the air quality monitoring. The device is something which senses PM 2.5 and PM 10 in real time. And then on the top right figure, what you see, we have tested a variety of network for campus-like settings, a small city, or let's say a small compound, which all have worked very beautifully, and it transmits huge amount of data every second, every minute as you want. One very important thing what we have done in this project is to calibrate these sensors. Remember that these sensors cost 1/50th of these imported instruments. So a very important issue is that you make them, these sensed parameter, precise and accurate, and for that we have developed a variety of machine learning AI technique. What you see, all these publications which have been peer reviewed and published in top journals gives the detail of those calibration techniques. We have also co-deployed these sensors with Maharashtra Pollution Control Board, which is the chief regulator of the state of Maharashtra, in the city of Mumbai at 15 sites. 15 sites have government expensive monitors housed there. We have co-located our sensors, and then we have looked into large amount of data, about 35,000 hourly data, and that shows that sensors can measure PM 2.5 with an accuracy of 10%. So that's as good as you can get with an R square of about 0.85. So these meet the similar statistical performance that have been obtained from elsewhere. For example, similar code deployments what US Environment Protection Agency has conducted in different parts of US. So in that way, sensors are looking quite good and they are ready to deploy in different places. So what you see today, on the 10th November, you see there is a very hazy sky. That shows we have high particulate matter currently in the atmosphere over Kanpur. Now, this is Satwam device that is measuring in real time PM 2.5. If you look at the number here, it's just moving around 200 microgram per meter cube. And we are co-locating these devices next to these regulatory monitors, the BAM devices which government uses to monitor PM 2.5. If you look at the number here, that also shows somewhere from 200 to 220 microgram per meter cube. So look that the two devices are measuring PM 2.5 in close agreement. If you look at this entire setup, this is our calibration setup where about hundreds of Satwam devices are being calibrated in order to deploy in the field in next few weeks. So if you look at current technology readiness level for PM, it is 9. For gas sensors, we also have looked into that very carefully, and the current TRL is 7. And for getting real-time chemical speciation. So this is a new technique we are working with computer scientists of IIT Kanpur, where we want to use sensors to get the identifications of sources, because first part is that you want to monitor pollution, and second you want to understand what are the sources of pollution so that you can go after them, you can mitigate them, you can plug them. The current way to monitor or identify sources are very expensive, time consuming, and therefore they are not scalable. What we are doing with these sensors is that we are training these sensors with those expensive setup, and then the sensors are going to tell us about the type and location of sources. And this is what currently we are working with Uttar Pradesh Pollution Control Board to deploy these sensors in the city of Lucknow and get idea about sources. If currently you look at the overall market potential of these sensors, so in India alone, for only PM sensors, the market goes about $200 million as of now. If you add the gas sensors to that and look at the complete end-to-end monitoring, the global market is expected to be about $5+ billion in few years from now, and India alone it will be about $1 billion market. So therefore there is a huge potential to fabricate sensors also, so that we are totally self-reliant and then start building these units for scalable deployment, and that is very aligned with Atmanirbhar program of the Government of India. So if we see how this work is slowly propagating into the monitoring domain of the country, so I am member of also another high-level committee of Central Pollution Control Board, which is mandated to come out with a protocol for hybrid monitoring, where these expensive monitors and sensors can be pulled together in an optimal way for doing the monitoring. We are going to soon chalk out a whole plan that how city level monitoring can be done. We are also going to help citizen-centric science with these sensors. The data which will be generated certainly is going to make citizens more aware, and which is very positive feedback that then air quality aware citizens can therefore put a pressure on policymakers, their local representatives, which certainly the demand for clean air would grow, which will be a win-win situation. And then if we can identify and mitigate these sources of pollution, it can avoid millions of premature death, and which is going to have a huge saving on the India's GDP. And as I said, that even outside India there is substantial market demand for these sensors, so we can definitely cater to that demand. And finally, one can take science-based decisions on hotspot, neighborhood monitoring, and better urban planning. So these are a couple of other associated ancillary benefits one could derive from these sensors. So finally, I will say that sensor-based monitoring is the way forward to tackle, monitor, and address air pollution problem in this country. I'm very thankful for giving me this opportunity to present our work at IIT Kanpur, and I also thank all my collaborators, students, postdocs who contributed to this work. Thank you very much.